Next section talks about the properties of logarithms. The first of them would be changing the base into something we can handle. Your calculator can only, well, maybe new calculators can, but typical calculators will give you a log, just log, and that is assumed to be base 10. So if you see base 10 here, that means just log. All right, and base e is ln. We talked about that before. So this is how you change the base. If you have the log of a base of something and then of your actual value, you take the log of whatever base you want of the actual value goes in the numerator, and the log of the same base that you've chosen, and the previous base would go in the denominator. So if you can see here, we've got log a. Our original base was a. That a goes in the denominator. And then we have the original value of that log is x, and that goes in the numerator. Our new base is whatever it is. B here, base 10 here, base e here. So base 10 and base e. Works the same way. All right, so there's some problems on page 383 that we can do here. Let's give it a try. Basically, they want you to change base group of problems, so I'll do a couple of those. In problem number 5, they want us to change the base of log base 5 of 16. Well, the 16 will go on top and the 5 will go on bottom. I'm going to use, what does it want? Well, it wants us to do logs and then natural logs. So as a log, so part A would be log of 16 over log of 5. And that's equivalent to ln of 16 over ln of 5 as well. All right, number 6 is the same sort of thing. So this one is log base 1/5 of x. So that equals log, which is again assumed to be base 10, log of x over log of 1/5. Okay, and well, I guess that also equals the ln. So this is part B, this is part A, this is part B. ln of x over ln of 1/5. All right, the next group of problems wants us to evaluate the logarithm using the change base formula and round the result to the nearest to 3 decimal places. So let's do one of those, and I'm going to make up one we can actually do by hand. So let's do number 9. So number 9 is log base 3 of 7. So again, we can do the same process we did in 5 and 6, and that's going to be log 7 over log 3, which is the same as ln. Let's fix that. ln of 7 over ln of 3. And let's calculate. We don't know what the ln of 7 is or ln of 3 is. If it was, e instead, or 10 instead for the logs, we could work it out, but we can't do it right now. So let's check it out on the calculator. All right. So the log button is to the left of the 7 here, and the ln button is right below it. So let's try the log of 7 first. So log 7, and then we'll divide that by log of 3. So we get 1.771243 and so forth. Let's do the same thing with ln to show you that it's going to be the same. So ln of 7, which is a different number. However, we're going to divide by ln of 3 and get the same result. It's same 1.77. So this is around 1.77. And let me make just a new one. This is just going to be an example. So what about log base 4 of 8? Well, I can change this to log base 2 if I want to solve it. Again, any b will work. So if I change this to log base 2, I get log base 2 of 8 over log base 2 of 4. Well, 8 is actually 2 to the third power, and 4 is 2 to the second power. So from our previous log rules, this equals 3 over 2.